As most of our regular subscribers know, I have been fascinated for many, many years with this whole idea that the speed of light is not a constant but slowing down. And I'm indebted to my friend Lambert Dolphin, who first introduced me to that idea. But clearly one of the real pioneers of this thought was a gentleman by the name of Barry Setterfield, who makes his residence in Australia. And his writings, of course, have been very, very controversial, created a major, major uproar in the field of physics. Most classical physicists have a great deal of difficulty in dealing with this. I think that's not surprising because the speed of light was regarded as infinite during the days of Descartes and otherwise, and it was Olaf Rømer, the Danish astronomer, that first actually found a way to measure the speed of light, and his results were just disputed out of hand for 50 years by physicists until James Bradley, an Englishman, confirmed his results, and people began to realize that the speed of light it did travel at a finite speed. But the field of physics, of course, has clung to its belief structures just as tenaciously and emotionally as any other field of study. But in any case, Barry Setterfield, much vilified by many, was the first to really unearth this possibility that the speed of light's been slowing down. It's still controversial, but extremely provocative because it really addresses many of the paradoxes that occur in astrophysics in general, and certainly in terms of the biblical believer who's constantly struggling with this issue, gee, were we created in 6 days? And how could it be that we see light traveling from 50 million years ago and all that sort of thing? So it's a basic issue that we wrestle with. So I have been fascinated with Barry Setterfield's studies and observations for many, many years, and I was delighted that on a recent trip to Australia that I had the opportunity to actually meet with Barry. Now, Barry has the burden of dealing with an autistic epileptic sister, so he finds himself unable to be away from her. So it makes his travel very, very burdensome, and for that reason he doesn't have the visibility that many people wish he did have, just really through his writings. But he did make our special arrangements while I was in Adelaide to come see me, and we spent a delightful afternoon. It gave me a chance to hear from him personally the remarkable aspects of his discoveries, and also to confirm what I had heard, that he's just a warm, committed, believing Christian guy. And I just had a wonderful afternoon, and we did record it, and we thought you would enjoy joining us for an afternoon discussion with Barry Setterfield. Tell me how you first encountered and dealt with this whole issue of the speed of light issue. That's this whole business of the possibility of the speed of light not being constant, of course, is the primary controversy that tends to surround your name, because you were early in alerting the world to that possibility. How did that first come up? You want to tell me about that?
Do you really want to know that, Chuck?
Yes, yes, I do.
Okay, it came in two sections, really. I was alerted to this by an experience that I had back in 1973. Let me just backtrack just a wee bit, Chuck. What happened was that when I became a Christian when I left, just at the point of leaving university, I had to leave because of ill health, which is why I haven't got any formal degree at this stage. Someone said to me, Barry, you're an unqualified success.
That's a clever double entendre, isn't it?
It is. I thought when I became a Christian, I thought God had done it through evolution. And then as I started reading the Bible, I found that, 10 times in Genesis 1 it said they were to reproduce after their kind, not change from one kind into another. And as I read the scriptures, I saw in passages like Isaiah 11, the lion will eat straw like the ox, the lamb will lie down with the kid, and none will hurt or destroy in all my holy mountain. And I thought, hey, this is God's normality for the animal world, not nature red in tooth and claw, not the survival of the fittest. So I had to change my ideas about evolution. And so, to satisfy my long geological ages and my long astronomical ages, I moved to a position where I thought, each day in Genesis has got to be a geological age. And then in the tears of despair one night, Chuck, I found that didn't work either scientifically or scripturally. And I moved back to the only other alternative that I knew, which had been presented to me by Dr. J. Sidlow Baxter in his work.
Yes. J. Sidlow Baxter is he's a legend,
Okay, so anyway, I fell back onto a gap theory. I said, there's this time gap between verse 1 and verse 2 in Genesis 1. I put all of my astronomical and geological ages in there, and Genesis 1:2 was the reformation of the earth to make it habitable for man. So you're familiar with the story there. But and I taught it that way at high school groups, for university groups, for scout groups. I taught it like that at Sunday school and so on. And I said to one of my friends who said, okay, well, what about the geological column? Can't you account for all of that by the flood? I said, look, I have hassles with that. But even if you could account for the whole of the geological column by the flood, there's one thing you can't get away from. These galaxies that we see 5,000 million light years away, it's taken like 5,000 million years to get here, so the universe has got to be 5,000 million years old. There's no way out. That was the end of the argument for me. And I went on quite content that I had the truth that way for a number of years. And then on the night of the 11th of January 1973, it was the Thursday night as I remember it, about 10:30 at night. I felt
obviously a key milestone.
Yes.
11th of January
1973.
73, okay.
At 10:30 at night. I felt the Lord walk into my room. I couldn't see him, but I knew he was there. I felt his presence. And I heard his voice talking to me. And I argued with him, Chuck, for 4 whole hours about the Bible, science, creation and evolution. And he slaughtered every argument that I put up. He left me totally without any defences at all on this issue. And by the time he'd finished with me at 2:30 in the morning, I was totally convinced that, okay, everything was created in 6 literal days of 24 hours each in the recent past, certainly less than 10,000 years ago. And he said to me, he said, all right, he said, at 2:30 in the morning, he said, you're tired now. I was mentally exhausted after arguing.
Your hip didn't hurt, though, did it?
No, only my head, Chuck.
Talking about Jacob wrestling with it.
And he said to me, you'll have other questions to ask after, and I'll come back and answer them. So I went to bed, fell asleep, and the following morning I looked out of my window as I woke up. I parted the curtains. I could see parakeets flying between the pine trees. I thought, hey, I wonder how Adam felt to have pterodactyls fluttering around his head. And suddenly the whole creation seemed much more intimate and personal. And then it hit me. My basic argument. These galaxies that we see 5,000 million light years away, it's taken like 5,000 million years to get here, so the universe has got to be 5,000 million years old. And I said, Lord, I accept all you told me last night. I can't do anything else, but I can't see my way through this one. And in that instant, I heard his voice shoot back to me, the same way as he'd spoken that previous night. He said, Barry, why do you assume that the speed of light has remained constant?
I've heard that part of it. That's why I was curious. I wanted you to get into this a little bit because it really was from that point you really started this investigation, wasn't it?
Well, the investigation didn't start until some time later, Chuck. I held that at the back of my mind as a potential answer to some problems. And I thought, okay, if we have to go into this, we can knock it over in a couple of weeks. But I left it there. I didn't push it. I had other things on my mind at the time. And anyway, it wasn't until December of 1979 that someone gave me a massive book for a Christmas present. It was entitled Mysterious Universe, a Handbook of Astronomical Anomalies by William Corliss. And 800 pages or so. As I flipped down the index to see what was in this thing, I saw the heading, Constancy of Speed of Light questioned. My ears pricked up. I thought, hey, what's going on here? And I flipped back to those pages, and there, on those pages, were documentation from the scientific journals in the 20s, 30s and 40s that the speed of light was dropping with time. And there's a whole blow-up in the scientific literature about this. I hadn't been told about that at high school or university. I was told the speed of light was constant. And yet here's this discussion going on. And my response was, wow, what God said is true after all. Oh, you little faithers. And it was from that time on, Chuck, that I started to investigate this. I had the physical proof in my hand that what I had been told by the Lord was true. And I moved once I had that physical proof. And I've moved on that ever since.
Well, tell me how you then proceeded. I'm very interested in this.
Okay, well, I started looking at some of the scientific journals that this was discussed in. And by by the time we got to, I guess it would have been 87, our report came out. I had a number of ad interim conclusions which I put out in the meantime. Nothing had been absolutely set in concrete at that stage. The first report of any substance, of the major substance, came out in 87, where all of the data that was available had been documented, not only on the speed of light, but on also the other associated atomic constants. Because as we looked at this, we found out, okay, if the speed of light is changing, other unfortunate things are going to happen unless energy is conserved in the process. And when you conserve energy in the process, you find that all the measurements of the associated constants are actually moving in the predicted way. So, in other words, the movement of the other atomic constants, and there are about 16 or 17 of them, they show...
But there's evidence of their moving, is your point?
Yes, they're moving lock sync with the speed of light.
Give me some examples of that.
Well, for example, the Planck's constant H. It turns out that H times the speed of light c, is an absolute constant, Chuck.
Why?
We have measurements from the most distant galaxies about this.
Because, see, that's where I've been fascinated with the possibility. If the speed of light's been slowing down, my presumption is it probably is tied to the Genesis 3. And in terms of entropy, the entropy of light, the product of them being constant. So the speed of light slowing down ties to this mentality that's also when we're speaking of Romans chapter 8, the bondage of decay and all of that. That's why I've always linked that the speed of light's decay as part of a derivative. I mean, if it's correct, then it's probably a derivative byproduct of the curse from Adam's sin. And that just fascinates me, because we know everything we know about the creation is post-curse.
Exactly.
And that's why I'm open to this kind of a perception, and I'm always amused at this incredible reactionary attitude of so many physicists that they don't even really want to examine the data openly, which I'm always amused by the non-objectivity of scientists. They're just as emotional as anybody else is, So now some of this involved collecting data from history.
Yes.
And how did you go about getting raw data from way back? What the speed of light's been measured 143 times in 300 years?
About 160 times, Chuck, in the last 300 years. And what we did, we went back into all of the documentation that had been given from the experiments that had been done and so on.
And those are available. You can find those.
Yes. This is all. In fact, I had the Flinders University Library, interlibrary loans, working flat out for me for a couple of months. I got to know them pretty well. In fact, in my report there, I thanked a couple of Ian and Kay and a few of the others who'd worked there so hard for me. And when the report was finally out, and I gave a copy to the guys at the interlibrary loan, I said to Ian, well, there it is finally. I said, look, you've given you some credit here. He said, Barry, it's been a pleasure to be working with you on such a controversial topic.
Little do they realise, huh?
Yeah, so we had something like 300 or 400 references in there to all the work that had been done. And so it wasn't only just the speed of light references. We had a lot of references to Planck's constant and many of the other associated physical constants.
That's the other loose end I want to track down, because I've heard that assertion. I'd like to understand some of the other physical constants. Is there historical evidence that they've altered?
Yes, there is.
And that's what I was curious about.
All of these measured values, Chuck, are moving lock sync with the changing
over
speed
what
of
period of time? How far back do we have reliable evidence
for
physical constants changing?
See, the physical constants were only known in their present form at the beginning of this century.
That's what bothers me. In other words, I assume that trying to infer changes earlier than the century is probably pretty tough or pretty tenuous.
On the other physical constants, yes, but on the speed of light, no. You see,
on the physical, I'm looking for non-speed of light kind of data that is supportive. You see.
Okay. Well, the other physical constants for this century are moving in the same way at the same rate of change as the speed of light is changing.
Give me some examples. I'm just fascinated by that. I think it's very, very fundamental to our case here.
Yeah. Well, one of the major things is, in fact, as I mentioned before, Planck's constant, and that has changed. That has absolutely increased. There is no question about it. As you look at the raw data, there has a systematic increase in Planck's constant over this century.
Interesting. Okay.
Absolutely incredible. And as far as the speed of light is concerned itself, there have been, something like 15 different methods by which it's been measured. Each one of those methods in itself shows a decay. When you put all the methods together, despite the statistical scatter of points that you have, there is still a decay. Michelson, one of the key
yes, I want to hear about him because he did that at the Naval Academy. I'm a Naval Academy graduate, so I've got to know about Michelson.
Yes. Well, Michelson, he did 4 determinations of the speed of light. The first 2 were with the same equipment. The second 2 were with the same equipment. In each case, the lower value for the speed of light came with the same equipment on the second determination. Mm-hmm. And the first group of experiments had a speed of light considerably higher than the second 2 group of experiments. Mm-hmm. And so Michelson himself, in his data, showed a systematic decay in speed of light. And the point was that on the second determination, with the same equipment, it was registering lower. Now, this is not just with Michelson. This has happened 3 other times. You had Peace and Pearson, you had Foucault, you had some of the others. They measured the speed of light with the same equipment at a later date. Not only was Michelson working 1873, the same year you had Simon Newcomb working independently to determine the speed of light. And at the same time you had a Russian working on the speed of light by a different method again. Within 12 months, each one of these determinations had come out. Mm-hmm. They were within 5 kilometres per second of each other. Mm-hmm. And that was 1873.
That's surprising accuracy. Of course, that was 1873.
1873.
That's surprising accuracy for that early.
It is. Well,
today it's quite a different thing, but back then that's impressive.
That is impressive, mm-hmm. And this made an impression upon Professor R.T. Burge, and Burge, writing in 1942-43, he said, would have been 42. He said the results obtained by Newcomb and Michelson and those other experimenters around about 1870 to 1880 are consistent among themselves, and yet their average is 100 kilometres per second higher than the current values of the speed of light. Mm-hmm. So he admitted that there had been a change in the measured
I
value.
see the point you're making. I got you exactly, because a different method, same time, etc., close congruence of their measurements.
And they hadn't been liaising with each other in any way.
And yet, at the same time, measurably, significantly different than today, or subsequent measures.
Yes,
gotcha.
And interestingly enough, Simon Newcomb himself made a comment about the earlier measurements around about the 1700s. He said, these older measurements of the speed of light are about 1% higher than the current values. And he had to admit that, despite the fact that he didn't believe in any change in the physical constants. Mm-hmm. And he admitted that the early values in the early 1700s, were in fact 1% higher than in his own time. And then history repeats itself when the measurements that Newcomb made were 100 kilometres per second higher.
Sure. Now that's a long time ago, 100 years ago. At this stage, I gather the measurements are getting increasingly asymptotic somehow, aren't they? So the degree of change is becoming minuscule. But is there even a measurable change in very recent history?
Yes. Now here's where we can come into another method of measurement, Chuck. Because the speed of light, the change in the speed of light affects all atomic processes. The atomic clock, the way that scientists measure the ages of the rocks, mm-hmm. the planets, mm-hmm. the fossils, the stars, it has various ways of being measured. Mm-hmm. The atomic clock, in all of its various forms, when the speed of light is higher, that was ticking faster. Mm-hmm. So when the speed of light was 10 times its current speed, the atomic clock ticked off 10 years in one ordinary year. And so this moves lock-sync with each other. Okay. And the problem has been, over the last, ever since roughly around about 1955, mm-hmm. atomic clocks have been used as standard equipment in laboratories. Mm-hmm. And so when you measure the speed of light using atomic clocks, you cannot pick up any change.
Because the yardstick's moving in the same direction.
Exactly, yes.
I should share with you, I was on the board of a company called Datum, a public company, and we acquired a company in Boston called FTS, Frequency Time Systems, whose primary claim to fame was cesium clocks. And I remember that board meeting still vividly. Bernie Horowitz was the president. He was excited about this potential candidate acquisition, and he told us about the cesium clocks and how they're apparently, as I recall, accurate to 1 second within 100,000 years. Mm-hmm. And I raised my hand as a board member, and I says, Bernie, I only have 2 questions. My first question is, how do you know? And everybody laughed. The second question was, who cares? And of course, how do you know became a discussion of the molecular behavior and all that business. And okay, I conceded that. And then the question of who cares. It turns out, of course, that time precision derives from that. You derive navigational accuracy, and that's not obvious unless you've been a navigator. That time is crucial to positioning.
Absolutely.
And so, of course, these clocks are the very backbone of the global positioning satellite system.
Yes.
And we were very early in that game. But I remember that board meeting very well because I got a lot of chuckles with the board. But it was a relevant question as a board member. This all sounds great, but what's the real relevance of all this? And so I remember that. Now, I understand the point very clearly. You're saying that as the speed of light changes, the intrinsic atomic behavior is altered, and therefore the clocks are in lockstep with that. Which raises another question, and this is a hard question to frame intelligently, but is it possible that it's not the speed of light changing, but the nature of time?
It's the nature of atomic behavior which is actually changing, Chuck. Can we just leave that question in abeyance just for a minute? There's a couple of points I'd like to make about these clocks and so on. The interesting thing is that Van Flandern, Dr. Thomas Van Flandern from the US Naval Observatory in Washington, back then he was director of the US Naval Observatory in Washington, and this is back in 83, 84, sometime in there. And he, for the best part of 10 years, had been measuring and noticing the difference in measurement between atomic time and dynamical time, which is the time that it takes the Earth to go around in its orbit once, or the timing of astronomical phenomena.
Or a solar or a sidereal kind of movement that we call dynamical time.
That's right, yeah.
Okay, I got you.
Okay. Dynamical or astronomical time or ephemeris time. You have the three. They're all talking about the movement of astronomical bodies, one way or another. Van Flandern picked up in that 10-year period that there was a discrepancy in the run rate between the two clocks. And he published it in a US Bureau of Standards magazine that came out. There was a conference about the constants. I think it was called Atomic Phenomena and the Constants, I think, something similar to that. And that was back in 84 that came out. And in that big pamphlet that was put out by the US Bureau of Standards, Van Flandern made a very interesting comment. He said, if these measurements have any significance at all, it means that the atomic clock, that atomic time, is slowing relative to dynamical time. And if the atomic clock is slowing, it means that the speed of light is dropping as well. And he was picking that up with the atomic clock, a comparison of these two times. Now you can push this a bit further, Chuck. Knowing that the atomic time is affected by the speed of light or vice versa, you can then start looking back into the past, into history. You have dating of historical objects in historical dates, comparing it with atomic dates that you're getting for these same objects. And you can make a cross comparison. And you notice a very interesting thing. As you go back into the past, the speed of light, the atomic clocks were running faster and faster and faster. They peaked and then they started going back down again. And this is picking up an oscillation in the behaviour of the speed of light and the atomic clocks. And as you do this, you find that there's a peak round about 500 to 800 AD, and it came down to a minimum, and this is something I was discussing with Lambert only about a week ago, 2 weeks ago. It comes down to a minimum round about 1980 AD. And this is another reason why everything was tapering off, getting much, much slower. And this is why we hadn't been able to pick up so much of a change in the speed of light back at that time. Both for two reasons. A, it was slowing down to a minimum, and secondly, the atomic clock was employed. And as a consequence, you weren't picking up any change. So there were those two reasons. And the other associated constants, which are not being, like the Hall resistance, for example, as you measure that, you find that Hall resistance is changing in such a way as to indicate the speed of light must have been increasing after about 1980. And there's another way of doing this as well.
Why would it be increasing? That puzzles me.
Okay, we'll come to that, to the solution to that one in a minute, along with your other question. The other thing which was affected by this was the the rate of rotation of the Earth, that in itself is a stabilising clock, a stable clock, relatively stable.
I should say relative, because it isn't smooth either, is it?
It isn't smooth, but there's one thing which has been very, very noticeable, Chuck. Ever since 1980, they have one-sidedly added leap seconds. Because the run rate of the atomic clock compared with the dynamical clock, in this case the Earth's rotation, has changed. And with adding leap seconds to the clock means that the speed of light must have been increasing from about 1980.
We mentioned that in our newsletter, but I don't think we recognize the significance of it. That's interesting.
Yeah, and so since then, there's been an increase as you translate that, the number of leap seconds that have been added and so on, as you translate that into speed of light terms, there's been an increase of something like 11 metres per second in the speed of light since around about 1980.
What is the significance of that increase relative to entropy?
I don't believe that... This comes back to the basic cause of the whole deal. It gets back to your original question there and so on, and why there should be this oscillation. And that's what my recent paper is all about. This is the one which we've just submitted to a secular scientific journal. And this is the one that we've got the layman summary all about. Well, all right, how does it all work? This comes back to the behaviour of the vacuum. When the speed of light...
The basic properties of space?
The basic properties of space.
Gotcha.
Yes.
Permittivity and permeativity and all that.
Yeah, permittivity, permeability and all the other properties of space. When those properties change, the speed of light inevitably has got to change. Now, this comes down to what we know about the vacuum. And it's only in relatively recent times scientifically that there has been sufficient information about what comprises the vacuum to be able to make some intelligent, to have some intelligent understanding about this. Back in the 17th century, if you had a flask which you could perfectly seal, you took out all air, took out all gases, took out all liquids and all solids, they considered that you had a vacuum. That was known as the bare vacuum. They found out later that that vacuum would transmit light, but it wouldn't transmit sound. Today, scientists don't use the term bare vacuum. They use the term the physical vacuum, and there's a difference. As they experimented, they realised, okay, that flask, what we now must do is surround it, make it a perfectly sealable flask, so that it's entirely temperature proof, so that when you pull out all your heat radiation from in that flask, so that flask is a perfect vacuum down at absolute zero of temperature.
So they've got to get to 0 degrees Kelvin.
Yeah. They make a discovery. There is still an intrinsic amount of energy within that vacuum. Within every cubic centimetre of the vacuum of space, there is an intrinsic amount of energy. It's called the 0 point energy because it's there at absolute zero of temperature.
I understand that part, yeah.
Okay. Right. That 0 point energy is absolutely ginormous. It has been estimated as being, some estimated as being infinite. Others say no, it is finite, but it's very large. I subscribe to that second deal. For reasons which are outlined in my paper. But the sort of orders of magnitude that you're talking about is something like of the order of 10 to the 95 to 10 to the 100 ergs per cubic centimetre. And that's 1 followed by 95 or 100 zeros. That is the amount of energy intrinsic within each cubic centimetre of space. And this energy manifests itself because energy can be converted into matter and vice versa. You have, the current view is that you have virtual particles popping in and out of existence, particles and antiparticle pairs. So you have an electron and a positron forming and annihilating within a very, very short period of time. Okay, that is one view. The other view, which is slightly more recent, is that view is known as quantum electrodynamics. The other view is the stochastic electrodynamics.
Okay.
This is saying that the energy there in the vacuum is made up of a whole series of electromagnetic waves, which is a sort of an irreducible noise in your vacuum, so that you have a number of experiments that you can do. For example, if you put an electron, suspend an electron in a vacuum at absolute zero temperature, the electron does this sort of thing. It jiggles around. It's called jitter motion, or it actually goes by its German name, Zitterbewegung.
What?
Zitterbewegung.
Zitterbewegung.
Yeah, it's
interesting.
it literally means jitter motion in German. And so the way that this is explained, you have one way of explaining it on the QED model. You have another way of explaining it on the SED model, the stochastic electrodynamic. On the SED model, you have all these waves impacting on the electrons from all different directions and jiggling it around. This is essentially what's happening. You've got, they call it the seething vacuum. You have, now this has got some, quite apart from the electron, you have another way of showing that this energy is there. If you take two parallel metal plates and bring them very, very close together, there is a force collapsing the plates. What is happening is that...
That's distinct from an electrostatic force?
Yes, quite distinct from electrostatic forces. This force actually goes as to the fourth power. All other forces can be shown to be different powers. But this force, it's called the Casimir force. It's known as the Casimir effect after Hendrik Casimir from Philips laboratory over in the Netherlands, who discovered it back in the 1940s. And it turns out that on the SED model, as you bring these plates closer and closer and closer together, the only wavelengths which are permitted to exist between the plates are those with wavelengths that are shorter or shorter than the average distance of those plates apart.
As a wavelength. Okay,
as wavelengths, yeah. So that means a whole host of waves are being excluded from those plates. And those waves exert a radiation pressure. And that pressure is what is pushing the plates together. So here you have two experiments to show that this energy actually does exist there in space.
Now, how does this tie, if at all? Maybe it has nothing to do with this. I may be mixing apples and oranges. But does the relevance of the experiment of Alan Aspect and his colleagues at the University of Paris, where they dealt with the Bell inequality, this whole business of non-locality, does this relate to this at all, or is this really a different issue altogether?
It is possibly a separate issue, Chuck.
Okay.
It possibly is.
Because one of the most bizarre discoveries in recent years is the realization that these subatomic particles have no locality, that they're immediately connected somehow.
Yeah.
And our whole perception of reality is thrown out the window as we begin to realize that this whole thing is almost like that our physical universe is a holographic simulation somehow.
Yes. There is, in fact, a link in this.
Okay.
Remind me about that question a bit later. There is a link in this, because you can show that they are communicating at possibly what was the original speed of light.
Ah, there we go. Because now that's interesting. Because that's part of the mystery, is that these things, the Allen Aspect experiment, the 9.5 centimeters, all that business, really led to that these particles are somewhat communicating faster than the speed of light. But that's the speed of light today.
Yes.
The idea there might be gravity waves or something else is a whole other conjecture. Who knows?
Yes.
Yeah.
You see, Van Vlanen's recent work that's just been published in Physical Review Letters A, I think it was, he pointed out that the speed of gravity, as determined by his calculations and the measured values that he's getting of the constant that he's putting in there, is very close to what I'm getting from my redshift values for the original speed of light.
Now let's stop for a second, because
we'll stop right at that point.
There's a tremendous issue to bring up here. I assume you're talking about William Tift and
we'll come to them in a minute. That's all last.
Okay.
That all follows as a result of your question about the.
Okay.
Okay.
This is fun. You have no idea how I treasure this time. I've been looking forward to this for so long, and I appreciate your taking the patience to tutor me on this. This is wonderful.
It's a pleasure to do this. So getting back to the vacuum then, and the energy that's there, it's very interesting. It turns out that every atom in the universe is actually supported by this zero-point radiation, zero-point energy. This came out in 1987 by Hal Puthoff. He did a very important paper back then, And it's never been refuted. In fact, it's been referred to many times as being absolutely top-notch. Hal Puthoff said, okay, we've got a problem here, guys. If you take quantum theory, you have an electron moving in an orbit around a proton, and according to quantum mechanics, it doesn't lose energy. However, according to classical electrodynamics, that electron should be radiating energy as it goes round in its orbit. Why doesn't it? And he pointed out that when you ask a physicist why it doesn't, he'll say because of Bohr's quantum condition. And then when you say to the physicist, but what does the quantum condition mean? The physicist starts to fumble a bit.
It's just an explanation that they don't know. But I mean, in effect, what is the real answer? Of course, all these things are really just models that are imperfect. So as we press these kinds of questions on those kind of models, it just reveals that our models are frail, because there's an electron that revolves. It's really more of a stochastic behavior in the first place, isn't it?
Yeah. Well, Hal Puthoff made a very interesting discovery here. He said, let's assume that the classical model of the electron radiating energy as it goes around its orbit is correct. Let's assume that's correct. And let's also calculate the amount of energy that electron should be receiving from the zero-point energy background.
Okay. I got it.
He calculated the power that it was losing, he calculated the power that it was gaining, and the two happened to be identical.
So it's a balance.
He made a very interesting comment. He said, without the zero-point energy, every atom in the universe would undergo instantaneous radiative collapse.
Which brings to mind, is it Colossians?
Yes.
Chapter 2?
Yes.
By him all things are held together?
Absolutely.
Interesting.
Absolutely.
Yes. Oh, wow.
So this huge amount of power that's there, Chuck, power belongs to God. Here is a manifestation of God sustaining all things with the word of his own power. It's an absolutely... Nancy, look, this power, 10 to the 95 ergs in just one little cc, and you look out at the vast universe there, that is almost incomprehensible. To give you an idea of how much 10 to the 95 ergs is, if you take the amount of power being radiated by the sun and multiply that by 100 billion for the number of stars in our galaxy, and let them burn for 1 million years, the total amount of that energy expended would be approximately equal to that. 10 to the 95. Yes. Look at that. How great, how powerful, how wonderful is our God. It's absolutely stupendous.
It's quite a tour de force, my friend. That's excellent. You betcha.
Now, okay.
I want to work our way back to William Tift and his work.
Yes, we're moving in this direction.
Okay, good. All right.
Okay, so given that you've got every atom in the universe sustained by this zero-point energy, you come back to the basis of your understanding of what the fabric of space is and what is happening to atoms. If every atomic orbit is maintained by the zero-point energy, if the zero-point energy changed, you would expect perhaps that the amount of energy in each atomic orbit might change.
Sure. Okay, it'd have to stay in balance, wouldn't it?
Yes. Okay. Now this is where William Tift comes in. Tift noted that the redshift of light from distant galaxies, well, the redshift for a start, as you have a look at light from the sun or light from other stars or light from galaxies, in that light you have a series of light and dark lines due to the emission of light or the absorption of light by various elements in those stars. And these dark lines appear in consistent patterns, not only for our sun but for other stars and for other galaxies. And for example, sodium vapor lamps emit a very characteristic yellow light. And there is two two dark lines in the yellow part of the spectrum, which are very characteristic of this sodium emission or absorption. It's dark lines if sodium is absorbing the energy. All right. As you look at distant galaxies, it turns out that these characteristic lines are shifted progressively further and further and further down to the red end of the spectrum. That's called the redshift. Now, astronomers back in the early days, back in the 1920s, they assumed that this redshift was due to
the Doppler effect.
The Doppler effect. As you hear a siren on a police car coming towards you, it gets higher, then as it passes you, the pitch drops. Mm-hmm. And they said, okay, the same thing's happening with light.
You call it Hubble's law after Edwin Hubble. And
yes, that's right.
That's really, the whole thing's a conjecture, isn't it?
Yeah. Mm-hmm. Well, they said, okay, Hubble did some measurements, and he said, look, the further out we go, the worse this redshift gets. So obviously, these galaxies are going away faster and faster from us. So the whole universe must be expanding. And that is the basis of the expanding universe philosophy, just this redshift. So they assumed that this was a velocity effect until William Tift came on the scene in 76. Mm-hmm. Well, Tift, as he looked at the redshifts of light from distant galaxies, he noted something. It wasn't a smooth function. It was actually going in jumps.
Discrete quantum steps, in other words.
Discrete quantum steps, yeah. Mm-hmm. It's like every car on the highway was travelling at a multiple of 5 kilometres per hour. You put your foot down on the accelerator and nothing happens until you put it down far enough and suddenly, bang, you're another 5 kilometres an hour faster. Mm-hmm. Unusual behaviour. And how could this possibly...
Well, you know what it can't be? It can't be the Doppler effect, because you'd expect all values, not just discrete values. So you know exactly. It's some other phenomenology, right?
Yes, exactly, Chuck. Mm-hmm. Okay. Well, there's a lot of dispute about this to start with, and then the evidence started piling up.
Of course, for some people, evidence doesn't really get in the way of their conclusions, does it?
That's always a difficulty inside.
Which is fine, that's human nature, but it always amuses me how these physicists try to say science is objective, when in fact they're just as emotionally committed to their traditions as the theologians or anybody else. So it's just the facade that I sometimes find amusing. But getting back to the issue, okay, so we have Tift. Now, Tift hasn't come to conclusions about that. He just reports the discrete steps.
That's right. Yeah. Yes, he reports the discrete steps. And when the Hewitt-Burbidge catalogue was published in round about 83, Redshift catalogue was published around about 83, it looked as if Tift was wrong, because all of the values didn't show this clumping which Tift claimed was there. Then Tift and Koch noticed something. They noticed that if you subtract the movement of our galaxy and our sun in our galaxy, if you subtract that movement away from the redshift as a genuine Doppler effect due to our motion, if you subtract that away from all of these redshifts, you find that redshifts across the whole sky are quantized. Mm-hmm. They are going in the jumps.
So it's the data is modified by our own motion, you're saying?
The data is modified by our own motion. Mm-hmm. But once you subtract that out of the data, you find that, in fact, these redshifts across the entire sky are clumped. Mm-hmm. Well, he started off with his clumping at roughly 72 kilometres per second. And redshifts are reported in kilometres per second because they have assumed that the redshift is a motion.
They're imputing the idioms of their conjectures, in effect.
Yes, indeed they are. Mm-hmm. What, in fact, the redshift is measuring is the change in wavelength against the laboratory standard divided by the wavelength. So the redshift Z is a pure number. So you're simply measuring the change in wavelength, and the further out you go, the greater the change, divided by your wavelength. So all right, so it's a wavelength thing that we're measuring, and it's a pure number. It's got nothing really to do intrinsically with velocity that we're measuring. Well, okay, Tift then said he had noted a variety of other quantization figures. And up in 1991, around about then, 91 or 92, he noted that there was a basic quantization figure of around about 2.68 kilometres per second. Mm-hmm. That was the basic figure, which all the others were multiples. And he threw that at the scientific community, and they said, well, if you're going to have all of these multiple Redshift figures, how do we know if any one of them are genuine at all? And it came down to just a matter of, okay, well, statistically he's right, but what can we do with this information? And it's been there, sitting there as a conundrum all this time.
Well, just to make sure we understand each other, this basic number, whatever it is, 2.68, whatever, what you're saying is fractions of that never show up. It's always a multiple of that number.
Always a multiple of that number.
Which implies a digitization in a sense. It's a digital situation. It's not an analog situation.
Exactly.
Which itself is, even in itself is provocative. But go ahead.
Yes.
Yeah, okay, go ahead.
All right. So this is where we come back to the model of the vacuum again and the atoms. What we're looking at, as I said earlier, is a change in wavelength over the wavelength. This means that as you look back in space, the wavelength, the emitted wavelength of light from distant galaxies, from atoms in distant galaxies, because all light is emitted by atoms, this was actually emitted at a lower wavelength. A longer wavelength, which means a lower energy.
A lower wavelength.
A longer wavelength.
I got to think about that for a minute. I'm not sure there's a lower wavelength, lower energy.
A longer wavelength. As you move down towards the red end of the spectrum, Chuck, you're moving down towards the low energy.
Yeah, I understand that. I'm just trying to. Okay.
Okay. So if this light is shifted down to the red end of the spectrum in jumps, it's what we're looking at. When we look out in space, we're looking back in time. So, okay, back in time, the further back in time we go, the redder the light, the emitted light was. It was redder. At
the lower energy.
At the lower energy, yeah.
So that's where I'm sort of backwards. In other words, how are they picking up energy through time? That's my question, I guess.
Yes, we'll come to the answer to that one.
All right, this is exciting.
Okay. What essentially we're seeing with the redshift is light emitted from these atoms as we look further out in space, is going to a lower energy for each orbit. The further back you go in time, and it's going back in jumps.
Oh, it takes lower energy per orbit, you're saying, in effect. Am I?
Yes,
right?
That's right. Lower. Each orbit in the atom is adopting a lower energy state the further back in time we look.
But it's doing so in discrete steps.
Yes.
That's the problem.
That's the problem.
Now, it's like piano keys. There's no intermediate tones.
Exactly.
Yeah, okay, gotcha.
Exactly. Now, this problem is something which a physicist is more familiar with, because in the atom, just about everything goes in jumps. You don't have a smooth change in energy from one orbit to another. You have
The best example is like a violin, which on a violin string you can hit any tone depending where you put your finger. That's why it's discordant if you don't do it right. A piano, you can't hit a key and get a non-note. You see, that's sort of the idea. Just another way of looking. So the atom is in effect sending notes, but they're always discrete. They may change relative, but they're discrete tones. That's what you're saying.
Yes, exactly.
And so, okay, then why?
Okay, the question is why. Well, let's get back to Hal Puthoff then.
Okay.
If the 0 point energy background is maintaining each orbit energy, what we're looking at is the orbit energy increasing in steps with time. Okay. It makes sense that if you have an intrinsic amount of energy available to each orbit in the atom, if that energy increases gradually, the atom can't access that energy until a full quantum of additional energy becomes available to the atom. Okay, because everything is quantized, it goes in jumps. You need a full quantum of additional energy available to the atom, and then it would click over to a new energy state, a higher energy state, where it's emitting bluer light, because blue is the higher energy end of the spectrum.
We see analogies of that when you see a little bar graph done with LEDs, where it's trying to show you a quantity, but you don't see intermediate quantities. You just see if there's a row of 10 LEDs, 3, 4, 5, or 6 are lit to show you how loud it is or something, and you don't get a half an LED half lit or something. You follow me? you're measuring things, but it's always in discrete steps. So that's what you're in effect saying. It won't show till it. Now, again, I guess I suspect in our heart of hearts, we really don't know why that happens. We just know it's true of all quantum behavior, whether it's length, mass, time, energy. That's the whole reason they call it quantum theory. Everything's in steps. Why they're in steps, we don't know, except the possibility that this whole thing is a digital simulation. But let's not get into that right now. I want to get back to Tip here. Okay.
Yes. What I have done, Bohr, back in 1915, he showed that there were two equations which govern the behaviour of the atom. They call them the Bohr equations. Bohr quantized or put a quantum condition in one equation, which quantized the effective energy levels within any given atom. That was his contribution. What I have done is say, okay, let's take the second equation and quantize that as well. And when you do that, it means that each individual orbit can take up a new energy level if sufficient energy is available to it from the zero-point energy background. That's all I've done, and the whole thing else falls out as a consequence of that, just by quantizing that second equation. Okay, why then should the ultimate question comes down, why should the zero-point energy be increasing with time? Because that's essentially what it boils down to. If the light from the atoms is bluer, it means that the orbit energy is greater
right.
with time.
Why? Which means the 0 point is increasing.
It means the 0 point energy is increasing.
Okay.
So that is the ultimate question in this whole thing. I must also explain that if the speed of light, when the 0 point energy is lower, the speed of light will be higher. Because it's like the fabric of space. If I can express it that way.
You might as well. Isaiah did.
Yes. The fabric of space was thinner, and light could get through more easily.
It's so fascinating that heaven is so often spoken of in the Scripture as a scroll. He stretches the curtain of the heaven. Those issues, I'm not sure. It may be a little too much license here to apply that to this discussion, but I do think it's interesting that those terms, speaking of space, are used in the Scripture. But go ahead.
Chuck, it's more than interesting, because about 8 to 12 times in Scripture it talks about the Lord creating the heavens and stretching them out. Now,
does this imply that they're starting to shrink then, or is that pushing it too far?
Okay, let me just explain what the picture that we're getting from all of this. Up until now, scientists have said, okay, this redshift is a sign that the galaxies are fleeing away. But this redshift is quantized, it's going in jumps. There's the problem. If the redshift, in fact, is due to light being emitted from atoms at a lower energy level, that quantization, those jumps, those quantum jumps in the redshift, would have been smeared out if the universe was expanding or contracting. Can you understand that? It means, therefore, that the universe, the very fact that the redshift is quantized, means that the universe must be static. And back in 87, I think it was, 87, 89, Hoyle and Narlica showed that a static, matter-filled universe is stable against collapse. So, okay, we assume then that the Lord created the heavens and stretched them out and stopped. What does that do? Something very interesting. In the Big Bang scenario, at the time where you have massive inflation of the size of the universe, where it's expanding out rapidly, they point out that this puts a stress or a tension or an elasticity into space. The fabric of space becomes under tension or stress. It's an elastic tension. In the same way that you stretch out a rubber band, that thing is under tension, under stress. This is part of their equations. And they say that stress or tension should decay exponentially into another energy form, which is radiation. Okay, I've taken that and said, we agree with that scenario. The Lord stretched out the heavens, created this tension or stress. It changes its form into specifically the 0 point radiation exponentially. And this means that as with time, the 0 point energy is increasing as this tension or stress from the universe is decreasing.
No, it's a relief of that tension?
And it is a release of that tension. So the 0 point energy will increase with time. As it increases with time beyond each quantum jump, the atoms are going to assume a higher and higher and higher energy state, and the speed of light is going to drop.
No. How does it relate to entropy and the bondage of decay? Or does it?
It possibly doesn't, Chuck. All it does is say, okay, the Lord in fact has stretched out the heavens. It can't, in one sense, there had to be a certain amount of 0 point energy to start with to hold every atom in place. Otherwise the atoms wouldn't be there. So as the stretching out process took place right at the very beginning, and then...
Unless this relief of tension phenomenon was somehow, it's not necessarily intrinsic to the stretching, it may be just a derivative of the stretching, which could, or maybe not, be associated with the introduction of the entropy laws. I've been fascinated by the other equations that tend to look at entropy and light as reciprocals in terms of Planck's constant or whatever else, but the point is that intrigues me because because of this passage in Romans 8, that some of the bondage of decay is associated with a curse.
Yes.
And what we know is the entropy laws, and of course there are many scientists that really have a hang-up with that. They can't visualize the physical universe without the entropy laws working. So the proposition that they are derivative of Adam's sin, they can't handle. And my attitude is they can't prove to me that Adam and Eve lived in only 3 dimensions. Who knows how they stood when they were clothed with light before they'd sinned and all that stuff. So that's really way out there, so why worry about that part of it?
Yes.
But we do know that there's entropy laws. We do know that we're subject to bondage and decay, and we do know that that's going to be somehow dealt with when we get in the Romans 8 passage. So,
absolutely.
And that may or may not relate to this, the TIF thing and the speed of light slowing down. But I can't help but feel that there is a connection. It's all connected, yes. But that's an instinct more than an understanding.
Yeah, yeah. Well, I would say that this release of tension had to occur very, very early on in the history of the universe. Whether it was at the time of the fall or whether it was before, I'm not prepared.
Sure.
Scientifically, I would have to go right to the limit and say no, it had to be from the beginning. But Lambert would insist that no, it would be.
Yeah, Lambert and I are probably drinking the same bathwater in terms of.
That's right.
Yeah, right. Okay.
Well, this whole business is very interesting because this with this quantization of the redshift, it means then you can predict what the size of the speed of light was with each quantum jump. And with each quantum jump, the speed of light changed approximately by 600 times its current value. And so with each quantum jump, the further out you go, the higher was the speed of light. So that right back at the moment of the creation of the universe, the speed of light was something like 2.54 by 10 to the 10th times its current speed.
Well, that's virtually infinite then. I mean, it's really fast.
Well, it's not as fast as a recent paper by Ulbrich and Maguire. They published, I think it would have been in February, in Physical Review. It received attention in the London Sunday Times on November the 15th last year. That's 1998. The headline was, on the science page of the London Sunday Times, "Speed of light has changed."
I saw that. I was very disturbed that these guys could even discuss the subject without even at least a backhanded allusion to your early declarations. Now, here you are. When was it that you first announced this in the public paper? Way back?
87.
87, so call it, more than 10 years, 12 years ago. And creating all the controversy, taking all the flack and all the criticism and all the things. And for someone to even address that subject and not at least make a token allusion, pro or con, at least allusion to Barry Setterfield, the subject seems to me a little crass. But in any case, the very fact, though, that there are these kind of papers coming out even willing to discuss the subject, I think in itself is an advance. It fascinates me that the speed of light was regarded as infinite up until, from Descartes on, until Olaf Rømer did his famous thing, and it took when he measured the speed of light using the eclipse Io, and so it took 50 years until Bradley, the Englishman, confirmed his results. But for 50 years, the scientists, these objective super guys, were willing to ignore the evidence, to cling to their preconceptions. Yeah. And so the fact that you're catching a lot of flack, and there's a number of people, classical physicists, who sort of find it, are incapable of somehow considering these kinds of things, and I put it that way because it's not as if they have real hard evidence, they just sort of react. I think that's not surprising. It may not take 50 years, but I do sense that the field of physics is no different than... It's tragic because the field of physics has been the hardest of our scientists because they have the theoretical physics audited by the empiricists, and so somehow it's had a history of little more solidity than other fields of science. But even here, physics is really an emotional cauldron, particularly on this particular issue. So yes. I think that in itself is interesting.
Well, Ulbrich and Maguire pointed out that in their paper they had the speed of light 10 to the 60th times its current speed at the moment of the origin of the cosmos. And we're only 10 to the 10th, so I mean, we're pretty conservative.
And we're dealing, the other part of it, we have to be cautious here because we're extrapolating extensively from the rather limited data in terms of its precision, I think. So that's the other side of it.
As far as the speed of light is concerned with the Redshift, we've got solid data essentially from the...
Because it's digital.
Yes.
Yeah, okay, gotcha.
So we can rely on observational evidence for this right back. We can trace the form of the curve right back to the very, very early days of our universe, and this extrapolation involved in that is very little to get to that figure. But as far as the Ulbrich and Maguire paper was concerned, someone on the internet pointed out, they said, well, he didn't even mention Barry's name at all, or Trevor Norman's if it came to that. And they got a rather interesting response. The response came back, Ulbrich and Maguire are serious scientists. Setterfield is only a nut.
It's ad hominem. See, it's got what the slur is that he hasn't got his completed PhD credential and so forth. And I always regard some of these credentials simply as an evidence of insecurity in the first place. And the PhDs and the H2SO4s behind the name, whatever. So it's interesting. I learned something else in a totally different involvement. I was chairman of the board of a high technology company serving the defense community, and we happened to be in very, very advanced ultraviolet lasers, excimer lasers. And the top genius in our little enterprise happened to be a physics PhD from the University of San Diego, UCSD. And this was unrelated to all this discussion. This occurred long before I was even aware of your work, Barry. But I do remember, for other reasons, he made the point that one of the exercises they give their PhD candidates is to, assuming the speed of light was not a constant, to derive the implications of that in atomic behavior. And it's really done as an exercise, not that they believe that's a possibility particularly, but to cause them to think through the ramifications of atomic behavior that depend on C. And they have to competently derive. That was when I think maybe it's on their orals, but I remember he mentioned that because we were into another discussion that's part of their test of do they really understand what they should understand about the whole area of subatomic particles, atomic behavior, the rest, how it all derives. If C increases or decreases, what's the implications? And I was very fascinated by that because at least if nothing else, within that community, there's an acknowledgement of those interrelationships as being related, and thus becomes a chain of challenge to the change of a constant. And I do understand, I haven't actually seen that quote, but I understand that Einstein himself expressed doubt that there was any constant in the universe. I mean, he sort of reluctantly accepted light for a variety of reasons. But I get the impression even there he had his misgivings, if you will.
Yeah. Well, that's it's very interesting. Just on this issue, the discussion in the scientific journals continued up until August of 1941. And
41.
Yeah. What happened in August was that two things. First of all, I was conceived. Mum noticed this. She considered this significant. But in that month, R.T. Burge published an article which started by saying, "This article is being written at this time upon request, and any belief in the change of the physical constants of nature is contrary to the spirit of science." And then he proceeded to lampoon the whole idea of the changing speed of light, and that effectively closed the discussion in the scientific literature. So, yeah, this article is being written upon request and at this time upon request. Any belief in the change of this physical constant of nature is contrary to the spirit of science.
Tell me a little bit how Alan Montgomery got drawn into this whole discussion. Where did that? Is that through Lambert or is that?
That was through Lambert. Yes.
Okay.
Because
now he's a Canadian statistician. Isn't
yes,
that correct?
Canadian statistician. Mm-hmm. Yeah, and he did after we'd done our initial stats on this back in '87. What happened there, Chuck? I had some very good rapport with the maths department there at Flinders University through Trevor. We'd discussed this with a number of the scientists there. And the maths department were wanting us to put on a seminar about the whole issue. And that was about to proceed when, unfortunately, some creationists over in America made things very difficult for us. Mm-hmm. It was a real shame, really. Lambert feels it's possibly because they had not been able to get anything published in a secular scientific journal themselves, and they were just a bit annoyed that this had some degree of credibility there.
So it's human nature, and it's too bad, but okay.
Yeah, but back in '87 when our report came out, it was very definitely through ICR. That was the problem there.
Okay.
And there were ad hominem attacks there, of course, but they tried to attack the stats. Well, we'd done some basic statistical work there. And Trevor and I had a number of discussions with the Professor of Statistics down at Flinders University, and he said, "No, you have done things the correct way." Where Ardsma and the others had pointed out other statistical methods should be used, the professional statistician said, "No, you are correct." And it is very interesting, in all the ensuing argument, these professional statisticians said we were correct, and it was the amateur Christian statisticians who were saying, "No." It's amazing. It's amazing.
What I've seen in other areas doesn't surprise me. It's disturbing that there's all these tension-creating activities that within the Christian body that seem to be so counterproductive. Rather than competent secular attacks, it's really some of these, as you put it, your amateur internals. Not that, and again, the issue, it's not a question of which is correct, it's a question of openness to the possibilities that always bothers me, I think it's so foolish for us in areas like this to be dogmatic and it always, but yet it disturbs me that there's this just basic emotional resistance. Well, it is what it is, and people are what they are. Now, what do you think's the next step? What do you foresee coming down the pike as a result of this? You've got some papers that you've provided us copies of, and I'll try to understand them in my limited thing. But they're pre-publication. You've submitted these for publication. Do you have any feeling for when you might get this refereed or whatever?
Okay, it's being refereed at the moment, as I understand it, Chuck. The paper was initially sent to Foundations of Physics.
Okay.
They didn't even referee it. They bounced the paper straight back to me.
Without refereeing?
Without refereeing it. Yes, they didn't even referee it. They didn't. The comment was, there are 43 pages in it. They said, "This paper is not substantive enough or backed by sufficient evidence." And here am I with 100 equations and something like 105, 110 references and 43 pages. Not substantive enough, not sufficient evidence for us to consider it publication in our journal. Well, the fact they didn't even referee it makes me feel that, okay, it's probably too hot to handle. That was probably the problem.
Well, are there alternative publications, though?
Well, yeah, what I did, I looked around and I saw that it was Journal of the Astronomical Journal there in America. They have been publishing a lot of the results from NASA space probes and from the Hubble Space Telescope and this sort of thing. They're probably more open to new ideas than some. So I've submitted it to them, and as yet I haven't heard a response. They are presumably refereeing it at this stage. So I'll get back to you and let you know what the reactions are there.
Have you thought about doing a little book? Going back to the history, some background, some historical thing, and in other words, make it so a layman can follow most of it, and put the more technical papers as appendices or something, but to do it as a book that might reach a market and in fact might generate some more meaningful economic results. And
well, as a result of the layman's summary that I have put out to a few of my friends, they have suggested that should be the basis of a book. Well, in fact, before the 87 paper came out, I had already written about 5 or 6 chapters of a book about the speed of light, all the measurements that have been done, the way the experiments were conducted and everything else on a layman's level. And so that is already sitting there. I can add into it from this point.
I've always been mystified by the debate anyway, especially by guys like Hugh Ross, because anyone that has even a modicum of understanding of Einstein's general theory of relativity, and certainly Hugh Ross is incredibly competent in that area, can easily duck the issue. Was the universe created in 6 epochs, or was it 144 hours? And you duck that simply by whose clock are you talking about? If time varies with mass, acceleration, and gravity, whose clock are we talking about? Adam wasn't around; his clock wasn't running. And you're talking about God. What's his mass and gravity? Come on, get serious. Jerry Schroeder, the physicist, the nuclear physicist in Jerusalem, good friend of ours, he has an interesting thing he does. He takes the mass of the universe, which apparently is estimatable and finite. He takes the mass of the Earth. He plugs them in the equations, which in effect says, here's an observer at the surface of the Earth, here's an observer at the perimeter of the universe. And he says, and it turns out that the ratio is 0.061. Anyway, it turns out that the 15 billion years or whatever turns out to be 6 days. Now, it may be just a coincidence and may be taking some liberty, but he's quite serious about presenting that as a thing.
In fact, he presented that in the Jerusalem Post, or one of the Jerusalem papers there. And a friend of mine over in Tel Aviv wrote and said, "Hey, Barry, answer this guy." So I sent an answer back in a letter to the editor. I said, he's got the right idea here, but he's using the Redshift and the to give you the age of the universe in actual terms. But I said, what he's done in one thing is that. What I'm doing is something slightly different here. Sure. And there's a different interpretation. When you take this difference in interpretation, you come out with a very similar result.
Sure.
But instead of the whole cosmos being in fact 15 billion years in actual time, it's only 6,000 years in.
Well, I think Jerry, in fairness to him, if he was here, would agree. He advances the argument in seriousness. What he's really doing isn't advancing that as an argument cosmologically. What he's really doing is kicking the anthill for us to recognize that you're dealing with 2 different time frames.
Yes.
And so the problem we have is not Genesis 6 days. The problem is Exodus 20 verse 11. Mm-hmm. God clearly intended us to understand them as literal days. That's our problem.
It is.
And you're right. The epoch issue doesn't compute for a lot of reasons, but that's subtle and takes a little more sophistication. The real problem isn't Genesis 1 and 2. The real problem is Exodus 20 verse 11. Yes. Because God, for whatever reasons, clearly intended us to understand that, to view it.
And I actually used that one in my letter to the editor in refuting. And I said, surely Israel, of all peoples on earth, should understand the significance of the Sabbath in the context of Genesis 20 verse 11. And I said, under those conditions, Gerald's argument just cannot hold up, because he doesn't see it, at least on the presentation that he gave there. He didn't see the Sabbath as a literal 7 days. He was looking at this as a period of many, many millions of years. And so
you see how that was created for the benefit of man.
Exactly.
Well, we have to leave now, the interview with Barry Setterfield. It was nice that Nan was also with us, because as Barry would turn in tutorial asides to her, I'm sure there were remarks that were useful for our listeners to keep us, Barry and I, from getting down too technical labyrinth of some kind. So that was a very special time for me. And I also should mention that Dr. Gerald Schroeder, Jerry lives in Jerusalem, is a dear friend. He also was kind enough to endorse our book, Cosmic Codes, Hidden Messages from the Edge of Eternity. Jerry's a good friend, and his writings in this area are also extremely provocative. What is interesting, you may recall from the other tape, the tape 1, we talked about Erev and Boker, not as later coming to mean evening and morning, but originally meant dealt with the changes of entropy. And it's interesting that there is no Erev and Boker, or evening and morning, mentioned with respect to the seventh day on the Sabbath. Why? Because there was no entropy change. God is resting. And so this whole area, of course, is extremely interesting to me, and I hope was to you. And the opportunity to actually hear from Barry himself was a very, very special treat. Candidly, he and I went to dinner, and we had many hours in the evening just to wrap on this and related discoveries. But I do hope you enjoyed it, and hope this was edifying and gave you another insight, or possible insight, to the reality that the Bible communicates to us.
For a complete listing of materials to further enhance your personal Bible study, or to receive a free 1-year subscription to Chuck Missler's 32-page Christian Intelligence News Journal, contact Koinonia House at 1-800-K-HOUSE-1. That's 1-800-KHOUSE-1. To fax your correspondence, dial 208-773-6312. Or you can write to Koinonia House at P.O. Box D, Coeur d'Alene, Idaho, 83816-0347.